call that a 65. What I see as 60, you might see as 65, right? Does that make me right and you wrong?
No.
No, it means that we're using a tool that's so small that it's got 5 degrees worth of error on it. So here's what I advise. As long as you're within 5 degrees of my answer, either above or below, then we're good. If you're 40 degrees off, then we got a misunderstanding. But if it's 5 degrees, you're good. Find the missing angles that I haven't shown you how to measure, and tell me what you notice. This matters more than anything else, is for you to talk to your partner about the measurements that you have. You have 2 minutes to go. Yeah, eventually I just want to talk about what you I get 85 on that one, but I can see how you would, again, there's 5 degrees worth of, yeah, still within 5 degrees. Because I got 85, she got 95. If you're struggling with measuring the angles, please call me over. You got it? So write down anything you observe about any pattern. Hey guys, you have a calculator, right?
Yes.
I want you to play around with what these angles add up to. All of them, some of them. Do some experimenting. That's what I got. Yeah, I got it. So you have to pay attention when you measure. This is how we went to measure the angle we went past 90. So that means that I'm going to pick the higher. So this is 118. Which is the opposite. All right. For the sake of time, but also for the sake of a good conversation, I'm going to ask you to point your attention back up toward the front. Now, again, I said that if you have anywhere between, if you're 5 degrees from my answer, I say that's fine. Because we all kind of see things slightly differently. If we move the measuring tool slightly over one way, it can shift it off by 5 degrees, so it's okay for us to be 5 degrees off. Here's the thing I want you to notice. This is a quadrilateral, right?
Yes.
Yes. What should all the angles in a quadrilateral add up to?
360.
Let's test that out. Grab a calculator. Not just the people who have the calculators out already, but every soul in the room needs to grab a calculator. Because I want you to prove this not just to yourself, but prove it to your partner. When I add up my angle measures, 95, 65, 85, and 115,
You get 360.
I get exactly 360. Now I may be a little biased when I'm measuring, because I know what they should be adding up to. You know what I'm saying? I kind of like fudge the answer a little bit, like, it's close to 115, or I move my measuring tool a little bit, and we're all kind of guilty of that in one way or another. But you guys have the purer answers, which I think are the better answers, because you didn't kind of know in advance what this should be. So even though mine does a perfect 360, I don't care about that. Was yours close to 360?
Yes.
That's what's important. Yeah? Because we know that not in theory, but in fact, those angles should add up to 360. One more observation I want you to make. Quick note, all angles add up to 360. I would make a note of this. That's my shorthand for add up to. I don't want to give this away though, because you guys think pretty hard about stuff in this class. So do you find any other adding up patterns happening here? Anybody say anything? Let me give you a hint. When you look at the number 95 and 85, anything? What do those numbers add up to?
180.
What about 115 and 65?
180.
Aha. You think that's an accident?
No.
Probably not. So, check this out. These two angles, B and D, aka the opposite angles, are supplementary. These two angles, C and E, aka the other opposite angles, are also supplementary. So, I'm going to write a quick note. Opposite angles are supplementary. What do I mean by supplementary? That's 180. You're going to see later in the class period why that's the case, but I want to focus a little bit on vocabulary. A moment ago, I kind of rushed past it when I said, this is a quadrilateral inscribed in a circle. Have you ever heard of the word inscribed or inscription before today?
Yes.
Inscription? Let's talk about what inscriptions are. You ever heard of an inscription? Let me give you some hints. When you read novels, and even works of nonfiction, sometimes on the early pages, the very first pages of the book, you will find an inscription. And that is like something that says, to my dear father, Charlie. Yeah? My father's name is not Charlie. I don't know why I like that name. At any rate, to my dear father, Charlie, that's an inscription, right? They're dedicating that book or that work to dear father, Charlie. A different example would be inside some people's wedding rings, or like college rings, or other rings that they hold close to them. If you take the ring off, sometimes there will be an inscription inside the ring. You ever seen this before?
Yes.
Yeah? So like my grandmother's wedding ring had a message from my grandfather on the inside of it. That is an inscription.
That's so cute.
It's so adorable. At any rate, inscriptions happen when we either engrave things in stone or in metal. Why am I talking about this? Well, hopefully it'll help you connect. Can you kind of see how these angles are engraved into the circle?
Yes.
That's what I think of when I think of inscribed angles. They are inscripted, or inscribed, to be more grammatically correct, into the circle. So here we go. Grab your notes real quick. I want you to make a very clear distinction between two types of angles in a circle, and so I'm going to make the distinction super clear on the page for you. Draw your own circle out here where you have some white space near the top. Pro tip for today, I'm using a lot of different colors. I think they're helpful for a couple of these problems. So if you have like pencil and then two more colors, like a red and a blue or a red and a green, you might find that useful to use those. Draw a circle out here, just freehand. I'm obviously not the best artist, so you don't need to feel pressure to be either. But once you've drawn that circle, make a center of the circle. And then once you've done that, we're going to create what's called a central angle, which is we're going to make the sides of the angle into radii, or radiuses, to be more common sense about it. Now I know that looks like a Pac-Man who has opened his mouth too big, but really what we have there is a central angle. And a central angle is called a central angle because the vertex of the angle is at the center. Yeah? Makes sense. What we learned on Tuesday about central angles is, if I know that this angle, this central angle, is 100 degrees, and let's say I make up a name for this angle, it's angle XYZ. If I know that the measure of that central angle is 100 degrees, what is the measure of minor arc XZ?
80.
Say what?
80.
No, not 80. If the central angle is 100, what's the measure of the arc?
100.
Same, right? We don't have to do any fancy math, they're just the same. So the central angle and the arc that it opens up are both congruent. In contrast, today we're going to be talking about inscribed angles, and the rules are different for them. We're going to get a little bit into vocabulary land here for a second. Don't let me lose you. But I do want to make sure that you understand how to use words correctly when you're talking about this, because it gets a little bit tricky. This is an inscribed angle. Do you see how it's different than a central angle? Where is the vertex of the inscribed angle? It's not at the center, it's on the circle. So that's part of the definition if you look over here. An inscribed angle is an angle whose, there's two parts to the definition, whose vertex is on a circle, that's number one. Sorry that I keep moving, try not to. And then the other part of the definition is whose sides contain chords of the circle. So instead of the sides of this angle being radii or radiuses, the sides of the angle are chords. Really quick thing with vocab, I'm not going to teach you about intercepted arc and subtend because nobody actually speaks that way. I mean, in theory they do, but they just don't. Like, even high-level mathematicians don't use those words. Instead, I want you to write up here the phrase that you're going to hear me say a lot and that I'm going to teach you to use. I'm going to say things like angle B opens up arc AC. I would write that down because you're going to hear me say opens up when I'm referring to angles and arcs. Here's what I mean by that. If you take angle B and you follow out the endpoints where it goes out here at A and here at C, can you kind of visualize that as two arms? Like the angle is two arms? So think of the space in between the two arms. The space in between the two arms is the arc that the angle opens up. Make sense? That's going to be important for what we do next. So we're about to learn how to find missing angles when we're talking about inscribed angles. Well, it's relatively simple. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. In my own words, since I used a different expression, I'm going to give you a different definition. The angle measure is 1/2. That's not 1/2. Is 1/2 the measure of the arc it opens up. So, go ahead and go. If the arc here, AB, is 100 degrees, then I automatically know that if that's the arc opened up by this angle, then this angle must be 50 degrees. Exactly half that. Follow? Now, it starts out simple, but as usual, you got to kind of hold on to your basic principles. So I want to emphasize two things. The angle is half the arc that it opens up, right? What if I wanted to find the arc and all I knew was the angle? What would I do to the angle?
Multiply by 2.
In other words, do the opposite of what I did before. So sometimes you'll be missing the arc, in which case you'll multiply the angle by 2. Other times you'll be missing the angle, you take the arc and you divide it by 2. I want you, finally got some rain. I want you and your partner to decide upon A and B. I will tell you A is way easier than B. So talk B out. You got 2 minutes to discuss. Go. Use this basic principle to answer both those questions. Do I smell a soccer game right now? It is 2:30. Angle T, you should be done with that already. You should be focusing on QR right now. You're leaving Ramon, it's so sad. So sad that he's not going to do any more work. I don't. So, which arc does this mean? In other words, look at the arms of the angle. What arc? Which one? I don't see a P. I don't know. So by arc, what I mean is a portion of the circle. So this angle right here. Look at the arms of that angle. It ends at R and S, right? Okay. So I know that to find this angle, I take this number and do what? Cut it in half. So what's the measure of that angle? Nope, I'm talking about angle T. Is that angle right there? This T is up here. It's half of that arc, which is 48. What's that? What did you get?
Good luck.
What's happening?
Would they
So I'm trying to find all the arches.
Okay,
You got
it's
48
better to be
already.
curious and
You can
then
find this one by
because
doubling this
I
area.
have questions that go home and not actually
Jeez. Victor, can you grab that for me? Say one more time. That's not 50. Yeah. Let me give you a hint. Find QT first, and then work from there. And then, isn't this a diameter? Diameter split circles up into two semicircles. Yeah? Stay with me here. Diameter splits circle up into two semicircles. What's the measure of a semicircle? Ah, so this is 100. You're very close. Okay, Michael. Thank you. What is the measure of angle T? 24. Thank you. So measure of angle T is 24 degrees. QR is a little bit more complicated, so I'm going to give you a hint. And this is for the whole class, because I saw a lot of us struggling with it. TR, look at that segment. TR. What is that?
Diameter.
It's diameter. Finish the sentence for me. A diameter splits up a circle into two semicircles. And what's the measure of a semicircle?
180 degrees.
That's a hint. Did anybody find QT?
Yes.
Okay, what's the measure of our QT?
800.
It's 100, not QR, QT. It's double 50, right?
Yeah.
This angle opens that up. Isn't TQR a semicircle?
Yes. Yes.
And if it is, what's the measure of QR?
80 degrees.
I'm going to give you another round. Measure of angle G for number 1. I know it says red arc, so I'm giving you the exact thing I want you to find instead of printing things in black, white, and red, which I'm sure that the school would be thrilled at me using money that way. The measure of angle G and the measure of angle arc TV. You have exactly 2 minutes. You probably don't need that, actually. This class is too smart for that. You have exactly 1 minute. Why do I estimate you so high? Because whatever I estimate you at, you write. The trick.
Is that right?
Jinx. Cool.
Mentira. No? These are the opposites. But how? 90 divided by 2. 45.
You got it?
She would say though.
We're not going to give her a hard time. Well, we're not. This was half the 90. But if you have the angle, what do you do to that to find the arc? Okay, do that. Wait on her. Yeah. He doesn't look like that. He's asking me. Oh. All right, quick check. Enrique, what's the measure of angle G?
45.
45, so you took half of the arc to find the angle, yeah? Yaneli, what is the measure of arc TV? 76. You took the angle and you did what to it? Multiplied it by 2 to find the arc. Good. Any questions from those two people?
No.
Let's get to some actual challenge. Here's where your colors really come into play, is on the back. Oh, not that much, so no, stop worrying. So, I'm actually going to use some colors here because it helps me visualize what's going on, and I think if it helps me, it's likely to help you. The first angle I'm going to highlight in blue, which is angle AEB. And then the next angle I'm going to highlight in green, and that's angle ACB. I've been doing blue and red all day, and I just realized blue and green aren't different enough. Whoops. At any rate, we're going to make do. I'll refer to them, instead of by their colors, I'll refer to them by their angles. The vertices are at D and C, so I'm going to call them angle D and angle C, okay? I want you to look at this with me. You're really going to need to see what's up here in order to follow what's going on. 2 questions for you. What arc does angle D open up? Name it.
Arc AB.
AB.
Arc AB
Yes.
is opened up by angle D, yeah? What arc does angle C open up?
AB also.
2 different angles open up the same arc, yeah? Let's make up a measure for that arc real quick. Let's say that arc is 100 degrees. That is, arc AB is 100 degrees. The measure of arc AB is 100 degrees. What would I know about angle D? The measure of it is 50 degrees. What about angle C?
50.
So here's the theorem. If you have 2 inscribed angles that open up the same arc, those 2 angles are congruent. I'm going to write that down in what I hope is simpler language. If 2 inscribed angles open up the same arc. I don't like writing arc because it looks like R for me, so I'm going to write it uppercase. If 2 inscribed angles open up the same arc, then the angles are congruent. 2 inscribed angles open up the same arc, then they are congruent. I want you to demonstrate how well you understand that theorem by trying out 2 questions, this one and number 3 over there. I want you to find the measure of angle F for this one, over on the left. And then for number 3, I want you to find 2 things. Find me the measure of angle X, and find the measure of ZW, that arc. Work with your partner, you've got 2 minutes, go. Again, if using 2 different colors to highlight the 2 different angles helps you understand this better, do it. If it doesn't, then obviously don't. Which arc does angle E open up? To where? Where's the other, so the endpoints of angle E are G, where's the other one? H. So it opens up the arc GH. Yeah? What about angle F? What does it open up? Which arc? The same thing, right? GH. The endpoints of F are G and H, right? So, another way of understanding this. If this angle is half of this arc, then I can find this arc by saying 75 times 2. What is it? Yeah, so GH is 150. Then if GH is 150, isn't this angle half of the arc? So what is angle F? It's a different way of doing it. Yep. Let's try out 3 on 1. Can you answer? Okay. Yep, isn't the inscribed angle half of the arc? So if the angle is half the arc, if I want to find the arc and I know the angle, I multiply the angles. They're kind of opposite. Does You know how we got 72? Okay. We're about to shift to something else, but I need to make sure at first that you've got the basics kind of down. Luis, what did you get for the measure of angle F? 75 degrees. I'm only emphasizing that. I'm not being pedantic. I'm emphasizing that because I emphasize it on exit tickets. You lose points for things like that, right? I'm just emphasizing that there should be degrees there for talking about an angle measurement. Number 3, Nicole, what did you find for the measure of angle X? 72 degrees. Now, so far it's just been like, oh, I can read or I can take a wild guess, but this one you really can't take a wild guess at. You're going to have to know your stuff. What is the measure of arc ZW Betsy? What'd you get? And how did you arrive at the answer of 144 degrees, hopefully?
Since the measurement of angle X is 72, I just multiply 72.
The angle's half the arc, right? Yeah. So if we know the angle, we double it to get the arc. 72 times 2 is 144. When I had to be out on Wednesday, we're going to shift gears here real quick. Let me, before I do that. The remaining problems here are your homework, except for 2. Cross out 11 and 12. All other remaining problems, 3 through 8, and then problem number 17 are your homework. We're going to shift to something else real quick. The last document you picked up on the way in is something called Inscribed Angles and Circles Partner Worksheet. Now, I wasn't here to explain to you how this works on Wednesday, but I was hoping that the detailed instructions I gave you to solve were enough. I'm not sure if that's the case. So at any rate, I want to show you how these worksheets work because I kind of like them. And they allow you to work really kind of independently of me once you get the hang of it. We're going to work on this in more detail on Monday. So I just want to kind of get you introduced to this for the next 10 minutes. Look at question number 1. How many question number 1s are there?
2.
2. Here's the idea. If you're the partner on the left-hand side, you're going to be working in column A. Yeah? If you're the partner on the right-hand side, you're going to be working in column B. Now the only person... No, there are 3 people. Ramon, do you mind joining with Angelica real quick just for the purpose so you can have a party? And then somebody over here is just going to have to be there for 2 people that are A and 1 person that's B. Okay. Here's how it works. You don't really need me for a lot of this practice because the answer to both of these questions is the same. So how do you know that you're right? Well, chances are if you and your partner have the same answer, you're both correct. If you and your partner have different answers, then that means that someone has made a mistake and we've got to go back and look at our work. If that doesn't make sense, it's going to make sense in a second. Here's what I want you to do. Partner A, or column A person. That's a person on the left, right? Left, correct? Yeah. So person on the left, I want you to solve number 1 here under column A. Person on the right, solve this problem right here, column B. These are harder, so you're going to need to talk to each other. Now, does it make sense for you to talk to your partner about your problem? Are you doing the same problem?
No.
No. So talk to the person in front of or behind you who's working on the same problem, yeah? That makes more sense? Okay. Column A people, go ahead. Column B people, let me call something to your attention real quick. You see how this says 3x plus 20? It's referring to that angle that I've marked blue. So that angle's measure is 3x plus 20. You have exactly 2 minutes, go. Check in with your partner when you're done. If you have the same answer, chances are you're both correct.
They're so cool. They look like
Yep. Do you know that there's not super words? How do we know that? Well, I know that they add up to 180. I don't actually think I know what they're. What I do know is that they add up to 180, though. Can I solve that equation? That's what I would do. Where to find the angle. This angle is 160. See how it opens up this big major cup? The measure of the arc from H. Arc H. And then it's double B. Yeah. So this entire measure is 200. Could you write an equation that says this plus this equals 200? If you need a hint, that's what I'm here for, but you gotta call me over. You're really, really close, but I mean, not really fast. This angle opens up this arc. So you're using this line what this arc. From R to A. See what I'm saying? You want to call me? Good. You're right. That's 200. So write an equation. This plus this. Not yet. Sorry, one more time, Victor. No, not yet. You agree that CA is a diameter? This angle is the angle we're talking about. It opens up this arc, so I need to find this arc first. Then I
But I thought this is 200 and 200. She was
C6 plus 2 plus 120. Now look at it. This angle opens up this whole thing. That whole thing is true. All right. I hate to do this, but in the interest of time, let's take a look at what you should have. Did anybody feel confident about an answer to column A? No. There's somebody raising their hand, so not no. Yes. She says 13. Did anybody in column B happen to get an answer of 13?
I got 13 too. But A.
But A. Anybody in column B get 13? 13 is correct. I want to just explain a few things for you. If you're working on, everybody needs to listen to this because again, you'll see problems like this later on in homework and then on Monday. This angle C opens up a major arc, yeah? It opens up the arc HGF. Double it, what's the measure of that entire arc? 200. So I wrote an equation, I said this plus this equals 200. Make sense?
Yes.
I solved it down, x is 13. Now over here, those of you that struggle with column B, which is admittedly slightly trickier, would you agree that CA is a diameter?
Yes.
Watch carefully, guys. If you're not, especially my column B people, if you're not paying attention, you're going to miss it here. So that would mean that this arc here, CRA, is 180. I subtracted 62 from 180, got 118. I cut that in half to find this angle. 118 in half is 59. And then I wrote an equation. 3x plus 20 equals 59. When I solve that down, x equals 13. Here's what's cool about this partner practice, and I know that that was a challenging one. You will see a lot more challenging ones on Monday when we continue to practice this. But the idea is you check in with your partner and you know you've made a mistake if you do not arrive at the same answer. Do you know what your homework is?
Yes.
Have a great weekend. Leave your protractor on the desk, please, not on the floor.